Team bless. Just see Dr. Alhad is there in a waiting room. If you can admit. I have admitted Dr. Alhad. Yes. Tere sir, to make Dr. Alhad co-host. Alhad, good morning.
Morning.
Can we check your audio and video? Yes.
Yeah, you can see me.
Good morning, Alhad.
Good morning.
Alhad, Madam is also here.
Madam is also
there. Hi, Alhad. How are you?
I'm good, thank you. How are you?
Yeah, nice to see you.
Yeah, same here.
Yeah.
How is everything in Netherlands?
Going on well. Yeah.
Okay.
It's good, yeah.
So things are controlled now?
Yeah, things are in control now. Yeah.
Okay, now we can admit all the participants, please. As per the flow chart, everybody is in. Jyotsna, can you check it?
Yes, sir. So the first is going to be yes. Vinit sir, ready?
yes.
Yes, he's
there. Yes.
Principal ma'am is there. Yes, good morning, ma'am. Yeah, good morning. Then Santosh sir. Dr. Alhad.
Yes.
Am I audible?
Yeah.
Okay. Dr. Raul.
Yeah. Sir is there, already there. Yeah, we have checked.
Yes. Asgeka sir, am I audible?
Yeah. Good morning, madam.
Good morning, sir. Sir, we all are in to start.
No, abhi 10:53, so 7 minutes. Yeah. Just we have to wait. Yeah. Jyotsna, can you check with Anand Upadhyay? Rahul is known to Anand Upadhyay. He has to be there inside.
এক মিনিট ইনফো দিচ্ছি।
So he's having, sir, some net problem. He's trying to find out.
Okay, so let us just see and how whenever he is joining. Okay.
Yes.
Anand has joined. Girish sir, make him co-host.
Done, sir. Santosh sir, ready. Santosh sir. Santosh sir,
Yes, sir.
we are ready.
Madam, it's 11 o'clock. With your permission, can we start?
Start.
Vinit sir, over to you, please.
Thank you so much, Santosh sir. Very good morning and warm welcome to all the delegates for this particular session. This is the International INFOTHON Conclave organized by the Department of IT in association with IQSC of Thakur College of Science and Commerce. The guest for today's session, Dr. Ahlad Kuvdekar. The speaker for today's session, Dr. Raul Rodriguez. Honorable Principal Madam, Dr. Mrs. Chaitani Chakravarti, Dr. S.G. Asgekar, Dr. Santosh Singh, the conveners of this particular conclave, all the members of the organizing committee, staff members, and lovely delegates across the world. It's my great pleasure and privilege to welcome you all for the third day and the first session of this particular International Infothon Conclave. The journey of Thakur College began in 1992 with the junior college and followed with 1997 with the commerce section and then in 1999 with the science section. At present, the college is really proud of to complete the 3 cycles of NAC with A grade in the 3rd cycle. The college has been conferred with the autonomy by the UGC New Delhi for the period of 10 years with effective from the academic year 2019-20. The college has also been given the Best College Award by the University of Mumbai for the academic year 2018-19. And the college has got the prestigious ranking of Education World, 55th in India, 15th in Maharashtra, and 13th in Mumbai. With this brief introduction of the college, we are going to begin this particular session. We have with us Dr. Mrs. C.T. Chakravarti, the Honorable Principal of Thakur College of Science and Commerce. May I kindly request ma'am to give her welcome speech, please. Over to you, ma'am.
Thank you, Vinit. And good morning to all of you. It's my great pleasure to welcome you for the final day of the International Infothon Conclave IIC 2020. The conclave was based on theme Skill and Talent Enhancement Program STEP during COVID, and it had 9 different tracks. It set a new benchmark for us. In total, there were 4,503 participants who had registered for the conclave on various tracks from different states of India as well as Ireland, Canada, Iceland, Iraq, Oman, USA, and Australia. We are meeting at a time when the entire world is passing through a most critical time. During this tough time, we have spread education to about 15,000 participants who joined through our various webinars, conferences, and conclave. The technology will continue to plug and play a vital role in our lives during all times. It's important that technological progress keeps us in space with growing requirement, and we need to constantly brainstorm and share with our vision. Now in today's world, it is very important that we share. If we don't share, we cannot grow now. Keeping to yourself cannot make you efficient. Information technology has become more of a necessity for us now rather than a facility. The world has truly become a global village, and the thirst for more knowledge and information has been a driving force for all inventions in information technology around the world. Now life has become much less manual. It's simplified because of the advancements of information technology. With this, I welcome our session guest, Dr. Rahul Watson from Watson School of Business, Hyderabad. Sir, I welcome you once again today. You were there on a first day also, who is from Spain for this session. I also welcome my student Alad, who is the main speaker, who is the chief guest for the function. Alad, we are happy to see you and see you grow also great. That's also a great feather to our cap. I welcome all the participants, speakers, guests of the day, and all the delegates who has made this International Infothon Conclave IIC 2020 session a successful one. Thank you very much.
Thank you so much, ma'am, for your inspiring words. You are always the inspiration and guiding force for all such kind of programs where it is possible for every member of TCSC, Thakur College of Science and Commerce, to organize such kind of programs. Thank you so much, ma'am, for your kind support. Friends, we have Dr. Alhad Kubdekar, who is a British citizen and prestigious alumnus of TCSC, with this morning with us. He is the chief guest for the function. I would like to give his brief introduction before he is going to give his inaugural address. He has completed his PhD in Seamless Session Motility Framework for Next Generation Networks, that is in mobile computing, from University of Glamorgan, UK. He was the lecturer of University of South Wales for 6 years. At the same time, he was shouldering responsibility of the head for the Mobile Application Development Division, CMAS University South Wales. At present, he is in a position of CTO and co-founder of My Lifeguard Limited UK. He is the external consultant for General Dynamics UK Limited. He is the solution architect for ICE Wish EU project. He is also the head of the software development mapper of EU project. By now, he has developed around 24 mobile applications. He has won international patent to his credit with 11 prestigious IEEE research publications. With this brief introduction, may I kindly request Dr. Allad Koudekar to please address this session in the capacity of the chief guest. Sir, over to you.
Thank you, Vinit sir, and hello everyone at Thakur College and international participants as well. It's always nice to be in touch with our college where we started our career and then went on to do something really good in life. Basically, my area of work has been IoT for quite some time. Even before many of you must have heard about IoT, which is Internet of Things. Now, what is Internet of Things? Coming to that point, connected devices that transfer data over a network without any human machine interaction or machine to machine interaction are IoT devices. And there are plenty of IoT devices around as of today. You see a lot of things like the Philips Hue, Google Home, Alexa. There's a lot out there in the market. When I started, my first interest in IoT was at Thakur College in 2003, where we created sort of a little wooden box with relay switches in, and you could control it from a computer by pressing 1, 2, 3, 4. But things have moved on since then. So with this, I'm going to talk briefly about two types of IoTs. One is the industrial IoT and smart homes. Now let's focus on smart homes because every day you hear that there are new devices available in the market. And what is a smart home? So a smart home basically is a collection of devices in your home that are connected via network and should usually take intelligent decisions for you. But that does not happen anymore. What you do as of today is you go into your mobile app and start controlling the devices, and that's too cumbersome. So what you have today as a smart home is not actually a smart home. On an average, we have a lot of connected devices in the home. So for example, if I open my mobile app for my router, I can actually see that I have 110 connected devices at the moment at home. And what are these connected devices? Not just your laptops, iPads, mobile phones, but also things like wireless speaker systems. So here I've got an Alexa, which is basically a smart home speaker, which is also here you see a Google Home, which is a smart speaker as well. Then we have got thermostats. So I have a thermostat here. So this is actually a connected thermostat. So this can actually make decisions for me. So for example, while I'm coming home, my mobile phone, my car knows that I'm coming home. And at that point in time, it sets the temperature of my home and that's it. I've got a warm home to come back to. Then we have got monitoring systems. So I've got here a very interesting thing, which is like a security camera, but this is something we built. But what is interesting about this is it is totally wireless. You just put batteries in and just close this box and that's it. Your camera is ready. You don't need any wires. So there are a lot of devices like these. Now doorbells, for example, I've got a doorbell in front of my home. And during this COVID-19 times, my wife does not want to open the door because she does not know who is at the door. So she talks to those people over the mobile app to keep the social distancing. So that works quite well. You've got a lot of other small devices like a smoke detector, a light bulb. I've got a home energy monitor. So that tells me how much electricity my wife is consuming. So I can tell her that look at the bill. So I've actually got how much washing machine she used. I've got it on my mobile app. So I know how much money she has spent. Let me just show that to you because it's fairly interesting. So I make sure that she cuts down on all her washing because it costs a lot of money for us. So here you can actually see for May, she has actually done 24.21 kilowatts and we are just halfway into the month. So I can then multiply this with how much money I pay for this. And it gives me a lot of information. So every device in my home as of today is connected. Then the other interesting thing I've got here is a door lock. If you look at this door lock, it does not look like a door lock, but it has a very simple mechanism. It fits on the back of your key. So your key goes in here. And when you are near to the door, this turns around and basically your door opens. As simple as that. So you've got all sorts of devices like these. Then you've got smart refrigerators, for example. The smart refrigerator, I'll come to that use case a bit later. We have got laundry machines. We have also got water leak detectors. And this is a water leak detector, for example. So this has got a lead at the bottom, and when it detects water, these two come together and automatically the water is detected. There are many more use cases, but I'll come to that in a minute. But let me show you some other things like a panic button. If I press this panic button, I can receive a call, my lights turn on. There are a lot of things that can be done, but I'll come to the use cases in a minute. So there is a lot of things you can do with smart homes, combining these things together. And that is where I created a platform for all these devices to talk to one another, to make them smart. So basically, why did smart homes did not pick up? And the problem is that the users felt that it was, why do I need a smart home? That is the first question. If I ask my mother as of today, she says, no, I can get up, turn on the light by pressing the switch. Why do I need a smart home? So people did not feel the need for smart home. The other thing was there were quite complicated standards like Z-Wave, Zigbee, BLE. And to somebody like my mother, it is too complicated to understand whether if I buy a device, whether it will work or not. Difficult setup. People had a lot of difficulties in setting up their smart homes. A lot of times companies actually shut down and they have already invested in very expensive smart homes that do not work anymore. Like a light bulb previously costed $50, but then Wi-Fi came into picture. And then a light bulb of this sort cost only $10 to buy, which is much cheaper. And as I said earlier, were homes really smart? No, because you need to control them from an app or a tablet, which is not a really good thing. Then came Wi-Fi, and Wi-Fi was the savior. So a Chinese company started off building IoT chipsets called Espressif. And there was no need for a hub. And here I've got a Node MCU, which many of you will recognize. And this is a very nice little device that you can buy on Amazon or whatever for 200 rupees or 300 rupees. And basically you can program this chipset to do a lot of different things. So you can actually connect a couple of cables here to different hardware devices, and you can program it and start working with it. So this is a very interesting device. If you want to start off with IoT, maybe this is the best device for you to get started, cheap, and this should work for you. So basically, I will show you a few examples, for example, how this whole platform should work. Firstly, I do not believe that there should be a light switch. Everything should be automatic. For example, in the evening, just before sunset, all our lights turn on. Now, the other day I was replacing my router and my wife suddenly realized that the lights have not turned on. Otherwise, she has not touched the light switch for the last maybe 2-3 years. So now she realizes that, how do I turn on my lights? That is where the switch comes into play. But otherwise, you don't need to even touch a switch if your smart home is quite intelligent. Now I'll show you a classic example. I've got an Alexa here and that talks to our platform, and you see a light bulb behind me here. And I'm going to use Hindi as a language because I'm quite proud of speaking Hindi. When I see the other Europeans, they usually speak German, Spanish, and other languages. So let's try with this in Hindi. So I'm just going to ask our friend Alexa to turn on the light, but I'm going to do that in Hindi, and you will see the light behind me turning on. Alexa, सोफा को चालू करें. Takes a few seconds. Alex, yeah, and there you go. You can see. And the other day I said something funny, which I'm going to again try today and see if it works. Alexa, sofa ko lal kare. And my light bulb has turned to red. I can just say commands and basically it should turn the light bulbs on, change colors. Alexa, sofa ko band kare. And there you go, the light bulb has turned off. So similarly, I can do all those sorts of things on my Google Home as well. But do we actually need this? If your smart home is intelligent enough, you don't need any of this. So there are a few use case scenarios, especially during the COVID situation, that I thought about and which have been really useful to us. One is, before COVID, how many times do you go to the supermarket and not buy the thing that you actually need to buy? If I go with my wife, she buys everything on discount that is available in the superstore, but not the thing that she needs. So we make another trip and it's again the same thing. So we end up going 10 times to the supermarket to buy one thing, but we end up buying everything else. But if you had a smart refrigerator or a kitchen, they would know what things you're running out of, what groceries you're running out of. So in that case, basically it would just do an order by itself. It has your credit card number. Using AI and deep learning, it can actually know what you have been ordering very frequently, and it would do those orders for you. So that would be ideal, and it comes to your doorstep without having to think about what you need to order. Basically, the other thing it could do is your kitchen could actually send you out new recipes based on whatever you have at home, and then basically you could cook those things based on the common question that we have is, what should I cook tonight? That is the most common question in the home. What would you like to have for breakfast, for lunch, for dinner? And if you had those recipes that came automatically based on what ingredients you had, that would have been most ideal. Now with the microwave, for example, what we do is we have to read the instructions on the food product before we put it in the microwave. Rather than that, if I could just put it in the microwave and let the microwave figure it out and then heat the food for me, that would be the most ideal thing. But there's one more thing. During this COVID times, I've noticed a lot of groups on WhatsApp, people actually send out what they have cooked today. How cool would it be if the microwave just took the picture and sent it to your WhatsApp group by default, so everybody knew what you eat and they could comment on it or upload it to Facebook. Now, during this COVID times, there is also an extension to IoT. I do not like going to the hospital at this stage because I know what's going on. But I've got a blood pressure condition and that needs to be monitored. So what we did was we integrated a few devices, medical devices like this one. This is a pulse oximeter, and I'm just going to put my finger into it. It takes a few seconds to start up, but you can actually see my pulse in a bit. It will be quite high because I'm talking right now. So you can see my oxygen level and pulse rate. And this is actually getting uploaded to the server. So you could also have a glucometer, pulse oximeters, blood pressure monitors, and so on that are all interconnected. And at any given point, you do your measurements. If you don't do it, you get reminders on your phone. But as soon as you do it, it gets uploaded to the cloud. And based on whether it is out of bounds, whether it is high, your doctor will be notified, and then he can call you and say, hey, do this or do that. And that is usually useful in certain cases where it is too high and you don't know what to do. You need to call the doctor. Instead, if the doctor knows well in advance, he can call you. He can actually do a video call with you, and if it's more critical, he can even send out an ambulance for you. That is what could be done. Apart from that, what I said earlier was this panic button. Now, if an elderly person actually falls down, for example, he can press this panic button and immediately a call will be made to his next of kin or somebody. The lights will be turned on so that he's not afraid of anything. And this can be the future use cases in such sort of a scenario. And there's a lot of future to IoT. By 2025, we are expecting about 21 billion IoT devices to be around. Artificial intelligence will continue to be a bigger thing. Routers need to be more secure and smarter, which they're not at the moment. 5G networks will continue to fuel the growth of IoT. Our cars will even get smarter. They will have a lot of information. So for example, in my car, I've fitted a little unit which tells me how much my wife drives around so that I know what the fuel levels are, because previously she never filled up the fuel. And every time I had to go for a meeting, I had to fill up the fuel. before going. So I know all the information about that. And of course, all this comes at a cost. It is never free. So you always have security and privacy concerns, which are going to grow over and over again. Because if you think of a smart speaker like this, it records almost everything that you speak, and then they start giving you lots of advertisements and so on. So privacy concerns are a big thing. And security, we know that hackers will always want to hack into all sorts of devices, try to control them or create denial of service attacks. So there is a lot of work that goes around IoT security. So just to wind up, I just wanted to show you something very quickly that basically we spoke about the node MCU. So I just took this chipset and actually put it in a bulb. So this is the bulb with the LEDs on. And what you see here is basically the chipset, which is similar to this one. So you can actually put this chipset in any of the device, like the water leak sensor, for example, has also got a similar chipset like this one. So that's from my end, and thank you for having me on the call. And I enjoyed talking to you. Thank you.
Thank you so much, Dr. Allad, for your inspiring speech. Dr. Allad was the chief guest for this particular session. And we are going to start with the session now. But before that, I would like to request Dr. Santosh Singh, the convener of this particular conclave, to give the very purpose of this particular conclave to be organized. So may I kindly request Dr. Santosh Singh, the IQSC coordinator, as well as the convener of this particular conclave, to give us the idea about this particular conclave. Over to you, Dr. Santosh Singh.
Good morning, all of you, as we are already running short of time. So it's my pleasure to welcome all of you on behalf of Thakur College of Science and Commerce and as a capacity of IQSC coordinator for International INFOTHON Conclave 2020, step during COVID-19. Under the able guideline of our principal madam and management, IQSC of Thakur College of Science and Commerce, we take a lot of initiative for a quality education, for protection of environment, women empowerment, and community-based social services. There is an entire change in education paradigm which we felt during this COVID-19. The conclave adopt a theme skill and talent enhancement program during COVID-19, and it really share an insight into a recent advancement in the area of information technology and computer science and cutting edge in the recent research work. We have covered a wide spectrum of various topics in a recent innovation and development in the field of information technology. In last 2 days, 2,868 participants got advantage, and because of really sensible discussion on a chat box, we found how much there was interest. I welcome all the delegates, all the participants. I welcome Dr. Raul, and sorry for the delay. I welcome Dr. Alhad, and I wish here all the participant researcher and my fellow colleagues, you will have excellent deliberation for this last day for now the 3 tracks which are remaining. Thank you very much. Over to you, Dr. Vinit.
Thank you so much, sir, to give us the insight about this conclave. And now we are going to have a presentation by Dr. Raul. But before that, I would like to give a very brief introduction of Dr. Raul, who is going to speak on quantum artificial intelligence in this particular session. Dr. Raul Rodriguez is an assistant professor, artificial intelligence, machine learning, and robotics at Vauxhall School of Business, Hyderabad. He has done his PhD in artificial intelligence, robotics, and process automation applications. His various collaborations at the foreign level, the two to be mentioned very prominently are Oxford Brookes University, UK, and European Union government bodies, Brussels, Belgium. He is a registered expert in the artificial intelligence system, multi-agent systems of European Commission, and nominee for Forbes 30 Under 30 2020 list, which is a great achievement by Dr. Raul. He is co-authored 2 books, The New Age Leadership, A Critical Insight, along with Retail Store E. He has 70 research publications to his credit. He is a weekly contributing writer to various magazines in the field of analytics and emerging technologies, the research journal reviewer, and associate editor at the Springer Publications. With this very, very brief introduction of Dr. Raul, may I kindly request him to please proceed with his session on quantum AI. Dr. Raul, over to you, please.
I also request Dr. Raul to take your complete time because there is a lot of interest in your session. There were maximum participants for your session. So, sir, please take your complete time. Yeah. Thank you so much, sir.
I will do so. First of all, let me just share the screen so I can show the presentation. Okay, you can all see the screen, correct?
Yeah, it's correct, sir. It's visible.
All right. All right. So first of all, this topic is, as you can imagine, quite technical in nature. But I'm now going to keep it extremely technical because, of course, there are people from different backgrounds as well as non-tech people. Hence, it might not be adequate to go into all the coding area and quantum computing parameters. I'm going to touch upon it briefly, but overall, I'm going to give you in-depth introduction to what quantum AI is. First of all, what quantum computing is, then how it applies to AI, moving on as well, what are the current world applications, what could be the future applications, and how you, on your own, with your laptop, can develop a quantum algorithm, of course, basic one, but how can you work it around in your own home? So basically hands-on applications I'm going to discuss about and whatever you will need to know for the future, because right now, as you can see in the news, AI, blockchain, robotics is the main trend. For the upcoming future, it will be everything related to quantum AI. So let's just get the rolling here. All right. This is an index, as you can see here. This is what I want to discuss about. So first of all, of course, if you have any questions, just leave it in the chat. I will answer at the end. First of all, I'm going to work on the definition, particular definition on what quantum AI is, how it is formed. Then we'll go into the brief history of it. Why was it created? What is the origin? And what is the use of it? And then moving on into the algorithms, what algorithms are we using? So here we're going to get a bit more mathematical and application-wise, but nothing extremely technical that not everyone can understand. Then what are the essential elements involved in quantum AI? What is required to perform quantum AI and how to develop it? Then what has been achieved so far, which I might tell you has not been much because, well, we're in the year 2020 and quantum AI is pretty recent, so to say. Quantum computing is not so recent, but quantum AI it is. So we'll explore what has been done at the moment. And then what are the challenges, which believe me are many. And then what can we expect in the future as well, okay? So we are going to just run through all these parameters. I will, again, not keep it extremely technical. If you want to keep it technical, then that has to be another workshop altogether. Believe me, it will take a few hours for that. But anyway, let's run through it. If you have any questions, keep it in the chat, and I will answer at the end. All right, so what is quantum AI? As you can see here, quantum AI is formed out of the regular computing science. So classical computing is based on binary code, 1 and 0s, as you know, so 2 elements and can be either. In quantum computing, however, we have something called qubits, which I will explore a bit in depth later on. But qubit is an automatic simulation or conglomerate of 0 and 1, both simultaneously. So that is what the power of quantum computer is. Quantum computing can develop directly a conglomeration of both the parameters instead of being independent from each other. That is the difference that it sets from your regular laptop to a quantum computer. Your regular laptop functions on independent actions, either 0 or 1s. A quantum computer will function simultaneously on both of them, hence increasing performance and accuracy. And consequently, of course, it will increase the performance and the delivery of it. So keeping this in mind, what quantum computer is and how it works overall, now we're going to see what quantum AI is in its conglomerate. All right. So quantum AI is the conglomeration or the combination of AI, as you know, is artificial intelligence, which is the aim to give human-like intelligence or human-like cognitive performance to machines, which you might have come across already because you are all using Siri, Alexa, Cortana. You're using Google, which is, of course, induced by AI. You're all interacting with chatbots. So you know what kind of AI applications you are coming across on a daily basis. So we can assume that quantum AI is a combination of this AI along with quantum computing. So quantum computing is where we get a bit more complex. Quantum computing is a combination of physics, chemistry, and computer science, of course, and mathematics, which is involved in all of them. So quantum computing as a whole is a very complex field. It's a conglomerate of various multidisciplinary areas of knowledge, and it's formed out of this. In fact, quantum computing comes from physics, from quanta, which I will explain you the history in a while, But if the origin is from physics, it moved on into chemistry, analyzing, well, molecules, and then it moved on into computer science in combination with mathematics. So if you really want to get into quantum computing or quantum at any point of time, bear in mind that you will need to explore various areas of knowledge. Computer science alone won't do it, and it won't cut it. You need to have knowledge of physics, knowledge of mathematics, knowledge of algebra, and somewhat knowledge in chemistry or whichever area of expertise you wish to specialize upon. Similarly, AI is the combination of this. So just to keep it simple for you, quantum computing is the main area. And along with, we thought that, all right, let's combine it with AI, which are, both of them are two very powerful tools. If we put it together, we can really develop very hands-on applications and extremely useful for our daily routine, especially when it comes to pandemic times and, well, disease prediction, as well as disease prevention for the future outcomes, which is what AI is trying to do. And if we do it with quantum computing, can be extremely mesmerizing in terms of results. If you look at the screen on the lower side, on the lower right corner, you can see that the definition of quantum. So this is the technical definition of quantum. So quantum, as you can see, is the smallest possible unit within physics, of course, such as energy, matter, or light, for that matter. So how was this discovered? This was discovered by those two individuals, which you know already, which are Max Planck and Albert Einstein, back in the 1935. So they discovered something called the ultraviolet catastrophe. So if you are from physics background, you should know this already. In fact, you should be familiar, even if you're not from physics, you should be familiar with Einstein's discoveries. And when it comes to this particular area, they discovered that the light can be divided into small packages or quanta, which is where the quantum computing, the quantum term comes from. It comes from quanta, which is the smallest unit within the, well, the light is not a continuous wave, so it comes from that distribution of light. And what we know as ultraviolet light right now, which is used by law enforcement as well as medical departments in terms of detecting what is on a surface. So that is what we have been that's what the application is for right now. And that is how it translates into quantum computing. So that's, to give you a brief history, as you can see, it comes from physics in combination with maths and then moved on into computer science. Right. Now, what two algorithms can we use here? Well, I can tell you there are more than 35 algorithms that can be used in quantum computing. Of course, it combines with AI for that matter. But there are two main ones which were on daily basis, exposed on daily basis. One of them is quantum tempering, and the other one is short algorithm. One was created in 1989 and one in 1994. So it's been a while since it's been created. New algorithms have come across, yes, but these new algorithms are not really that, well, performance-wise, are not really developed to a point that we can implement them on daily basis, or we can implement them actively in our encryption or, well, our performance basis. So when it comes to the quantum tempering one, what we do with this particular algorithm is finding the minimum values in the functions. If you are familiar with algebra or mathematics, you come across functions on daily basis, algorithms and equations. So what the quantum tempering algorithm does is finding minimum values in the functions. Now, what is the use of this? For example, this helps us detecting faulty neural networks. This, of course, helps increasing the efficiency and performance. So when it comes to faulty neural networks, if you look at natural language programming, or we look at computer vision for that matter, that are two areas that you might be familiar with so far. So as you know, natural language programming is basically speech detection and speech to text detection. And when it comes to computer vision, where, well, face recognition, object recognition, autonomous vehicles. So all these kind of applications are being the ones currently implemented in the real world. If we use the quantum computing algorithm here, a quantum tempering algorithm, and we implement it into a neural network, we can detect errors that can escape to our human perception. So the main aim of using these algorithms is to detect something that us, as humans, cannot come across. Then if you look at the short algorithm, this is something you have come across on daily basis for sure. So this is used to decompose numbers into prime factors, okay? Without getting too technical, if you look at the RSA encryption for those who are from computer science background or have any knowledge on computer science and cryptography, RSA is an encryption used for various websites as well as government platforms, even their mobile network. And this particular algorithm is what is used to detect the prime factors and make it more efficient, the encryption in particular. But if we use quantum computing in the Shor's algorithm, it will render this particular application such as RSA, or when you use WhatsApp, you come across a message that says your messages are encrypted. So this particular quantum computing algorithm will render all those applications completely useless, because quantum computing will encrypt into 15 times more of what the current encryption is. So you won't really be able to break it. Even those so-called ethical hackers will have difficulties implementing it or coming across it at some point of time. And hence, it will be a quite complex task to develop it and quite a complex task to break the encryption by them. So as you can see, quantum computer can really increase our performance, our security, and our encryption basis in order to increase performance and develop more accurate systems and more secure systems for the future. These are just two basic algorithms. As I said, there are more than 25 algorithms, but well, let's just touch upon two, which are the main ones, because if I touch upon the 25 ones, I won't really be able to cover within the time that we have. So essential elements that you have to come across quantum AI. So quantum AI, as I told you, is a combination of quantum computing and artificial intelligence. Keeping this in mind, we have three main elements. One is superposition, the other is entanglement, and the other is interference. Now, these are elements from quantum computing, but applies the same way for quantum AI. Now, when you come across superposition, as you can see in the image here, there are two states which are happening at the same time. Now, if we take an example, it can be musical notes. If you play an instrument and you play, for example, two instruments simultaneously, and you play two similar musical notes on two different instruments, these particular notes are going to be superposed. So this superposition is what happens when two elements are happening at the same time, simultaneously. So when this happens simultaneously, what is happening is that the performance increases in terms of computing power. So this computing power is developed. When you use your laptop or your CPU or well, your mobile phone, you're using basically bits of zeros and ones. So you're going into one action or the other. You cannot go combine, you cannot go superpose. But that happens when you use quantum computing. On the other hand, you have entanglement. When you talk about entanglement, you're working upon two different particles separated and being apart, but at the same time being together. What do I mean by this? These are two particles within the algorithm, two elements within the algorithm, which are splitted by distance, but at the same time, they are interconnected by a common wave, a common group, which leads to being together at the same time, though they are keeping a physical distance between them. Of course, we are talking about, we're talking about the size of molecules, we're talking about the size of quantum bits, which are not visible at the human eye, at the human range of the eye, but we can understand it in terms of zeros and ones, how they are entangled. Lastly, we have interference. Interference is, as you can see, parallel waves. Interference is basically dependency waves, which add or cancel to each other upon performance. Now, how are all these elements, superposition, entanglement, and interference, being used on a daily basis? Well, these are used on, first of all, mobile networks. These are used on weather prediction. These are used on financial stock predictions, because we depend upon these elements depending on how the data is combined. So if the data is superposed, we'll apply an element of superposition. Similarly, if they're entanglement, and interference, if they're going side by side. In interference, each element depends upon each other. That means that if I go up, the other element will go up as well. And if I go down, it will come down with me. So there is an interdependence happening where an adding or canceling process takes place. But this is a very high performance element, which can increase the performance of the whole computer or the whole algorithm in a huge way. All right. I see some questions in the chat. At least I see one question. I will answer them now so I don't miss the topic so far. Okay, there is one question here from the Deepak Mishra, which says, what kind of operating system is needed to run a quantum computer? What are the major components and features of quantum operating system? Well, I'm discussing the features right now. In terms of the operating system, I'll tell you later. I'm going to show you an example. What exactly you require. So don't worry about that. I will come across that. And there is another question here below. What are the hot research areas in AI that I will also discuss later? And how long will it take to train a quantum computer? I will also discuss it later. Don't worry, in terms of practical applications, I will come across it later in a while. I will show you how to work it across in your home, particularly, and how to discuss it, and what are the limitations. Don't worry, keep your seats together. I will come across that. I can see there are more questions coming, but let me just first proceed. Then I will answer them on the way. Apart from these three elements that you came across earlier, superposition, entanglement, and interference, you have something called qubits. Now, this qubits is basically this. A qubit can be either 1, or can be either 0, or can be both. When you talk about your general computer, computer program, your laptop or your CPU, you can either be 1 or 0, that's it. When it comes to quantum computing, you can be 1, 0, or both simultaneously. So it can be a 50-50 or simultaneously 50-50. So what does it how does it help us perform? It helps us perform in a way that our overall activity in the algorithm gets, as you can imagine, improve and increase in terms of performance, because the performance is way faster as well as way more accurate. So this is what it leads to. These qubits are essential. That is what forms quantum computing. Without qubits, we cannot develop quantum computing. Now, the more qubits, the more accuracy and the highest performance. So as you can imagine, even if you have a laptop, the more memory RAM and the more GBs or terabytes that your laptop might allow, in terms of quantum computing, the more qubits you have, the more performance you can develop. And the more qubits you have, your accuracy also increases way faster in a very hugely developed way. So just to put it in simple terms, this is I hope you can all see the screen in full because you will need it. If you wish to take a screenshot of this, feel free. If you wish to, let me just give you the whole definitions here. If you wish for me to send you this code, I can also do it, no issues. As you can see, this is on Python. So those who are not familiar with programming language, which I hope all of you are somehow, this is Python programming language. You can use this on C++ as well, or Java if you like, or Julia for that matter. In fact, to my students at Watson, I teach them on Python and Julia. So if you look at Python particularly, which is pretty easygoing and the interface is quite friendly, user-friendly, you look at this particular algorithm, which is basically 23 lines of code, you can run a quantum algorithm on your laptop. Now, for this particular algorithm, you are going to only use 26 qubits, which is pretty small and not really so developed. Accuracy is going to be compromised, as well as the performance. So it's not going to really be a very powerful quantum computing algorithm, but still will do to perform certain tasks. What do you need to perform this particular code? First of all, you need something called PyQuil or PyQuil, depending on how you want to pronounce it. This is, as you can see, the definition I have placed here. It's a Python library used for quantum programming in general and quantum computing. This is using Quil. Quil is a quantum instruction language, which is developed by a company called Rigetti Computing, which you can Google it. Rigetti Computing is a very famous company which develops quantum computing chips and quantum computing motherboards. So when you develop this particular algorithm in your laptop, in your Anaconda navigator or your Python interface or terminal, when you come across this, you can use PyQuil, which will increase the performance and run the algorithm faster. Secondly, you can use KVM, which KVM, as you can see, is a quantum virtual machine Of course, you cannot run this on your computer per se on your RAM. You have to run this on the cloud. Just that you use, if you know Google Colab, if you have ever used Google Colab, which is basically programming in the cloud, so using the same parameters as Google Colab, you use KVM. So KVM is quantum virtual machine. You are using the algorithm and running it on the cloud. What do you get by running this in the cloud? Well, you get a powerful interface for one. Secondly, you get your laptop or your CPU not to crash, because this quantum algorithm is going to be slightly more powerful than what your computer can afford by itself. So that's one. And secondly, you will be able to as well perform on the algorithm on a very accurate basis and develop your performance as well as the tasks that you wish to achieve. 1 minute. Okay. So as you can see, there are going to be 26 qubits. As I said, 26 qubits is not much, not to say it's almost nothing, but still, to give it a try and learn how it works is quite useful. Now, what are we going to do with this particular algorithm? We're going to do something very basic, something not very complicated. And if you look at it, something not very useful also, but it helps you see how quantum computing works. As you can see on the last line where it says print, the command print, you have your quantum dice roll the time, and then you set the dice value, and you're going to print this. What are you going to do with this? You're going to predict a multi-outcome result. You're going to look for a multi-outcome result. Why do you use this here? Why are you rolling a dice? As you know, in any sort of game or poker, when you roll a dice, the dice has multiple results. Those multiple results normally go from 1 to 8, means 1 to 8, the numbers, or 1 to 6, depending on the dice you're using. So what are we going to do with this quantum computing? When we're going to apply it in a way that is going to predict the most adequate results and the multi-outcome results in terms of a dice. We know that there are 8 faces in a dice, and there are 6 faces in a dice, depending on what we use, but a quantum algorithm doesn't know. A quantum algorithm is not a human being, does not have knowledge of poker or any sort of other game. Hence, a dice might come across with multiple outcomes. So what this particular algorithm is going to do is going to predict the number of outcomes that are possible, how many times those outcomes will come across, and how accurate these outcomes will be, and how useful these outcomes will be as well. So as you can imagine, this application of quantum computing here is not very useful in terms of practical terms, but if we apply this particular algorithm, of course, this is a trial, this is for you to try at home, not for anything else. But if you apply this particular usage to, let's say, weather conditions or disease prediction, pandemic prediction, we can actually come across a number of pandemic predictions such as coronavirus or Ebola or malaria, and how many number of cases will come across and in what particular regions in the world. So as you can see, quantum computing can help us develop predictions way faster than what AI can do. And why we're combining it with with artificial intelligence is because we are taking the best of AI, which is the predictive tool based on data, because AI is nothing but data, combined with the power of quantum computing, that high performance, that high enable performance and high enable accuracy will give us the outcome desired and the number of predictions we wish to have. So as you can see, these both elements combined, AI plus quantum computer or QC, it can really be the future of the world. In fact, it is said to be the future of humanity and how we will perform from here on. So my advice for you, since this is going to be the future and there is no other foreseeable future anymore apart from quantum AI and robotics, my advice is get into this field quickly, like as quick as you can. Get through it and learn through it, memorize it, understand it, enjoy it, because you will need this for the future of jobs, for the future of performance, and the future of humanity by itself. So bear this in mind. This is very important. And I'm going to read the questions which are in the chat now. But before that, I forgot to mention something. Those who are not familiar with AI, as I can see, there are many people on the chat who are not really that familiar with AI. AI, you might have come across the buzzword of AI, like AI is used by everybody. AI is like everything anymore. AI is like a god right now for everyone. You can see startups, you can see government officials, not just talking about India, but talking about anywhere else. You see government, you see startups, you see companies, you see everybody on social media, especially now during this pandemic. As you can see, there are n numbers of webinars, and all the webinars, it seems like now we are getting all the experts around the world, and there are more experts per square meter than it was before. So everyone is talking about AI when they don't really know what AI is. AI is the combination of probability, mathematics, algebra, physics, and computer science. All right, probability, physics, and by probability I mean statistics as well, physics, maths, computer science, and algebra all together. That is what AI is. AI is nothing else. AI functions only and uniquely because we have previous data. Without previous data, AI cannot perform, and without previous data, AI doesn't exist. So bear this in mind, that AI is not a demigod. AI is not here to take over the world. AI is not here to kill us all and to perform some sort of Terminator-like reality with Arnold Schwarzenegger. It is not that. AI is here to help us increase our performance in our daily tasks. That's it. But nothing else than that. And those who you see online, because I see it on a daily basis, that they talk about AI is the only future, AI is this, AI is that, when they themselves don't know what AI is. AI is purely maths and stats, as I told you right now, and in combination with computer science, which is programming basically. So AI is not impossible to learn. Yes, it does take some efforts because you have to learn various fields, but it's not impossible. So it is very much it's very much possible to use it. It's not going to be a very easy journey to learn it, but it's not impossible at all. Similarly, with quantum computing, you have to learn it step by step. So first you go from computer science basics, understand physics, how physics work, and then go into mathematics a little. Algebra, of course, is important for algorithms, and then jump into quantum computing, combine both AI and quantum computing, and progressively, as the year passes, you will be able to see how the performance works. For example, I can tell you, before I answer the questions in the chat, I can tell you, as part of my PhD thesis, I developed an HR algorithm which resembles the Chinese social credit score system. The Chinese social credit score system, if you don't know what it is basically the tracking, the social tracking of all Chinese citizens. I'm giving them points in base of how good of a citizen they are. So this tracks their faces, their voice recognition, what they say, how they say it, why they say it, how do they feel while saying it, how do they perform, how they walk, everything is being tracked. So I developed an algorithm, well, oriented or based on that case study, apply for HR, apply for companies. So I tested it in Europe on a trial basis in a company and a law enforcement agency as well, because I had the access for that. So I tried it. And basically what the algorithm does is, if you install it in the CCTV cameras and you install it on microphones, the algorithm detects, detects various things. Among them is the faces, tracks the faces, recognizes faces, tracks what emotions they're feeling, what they are saying, what emotions are they feeling while saying it, how are they saying things, what word they are saying will impact the company in the long run, how are they walking, which employees are likely to leave the company, which employees are likely to stay for the longer time, which employees deserve to get a remuneration, and which employees deserve to get fired. So all this is tracked down into a very long algorithm, more than 12,000 lines of code. Like I repeat, 12,000 lines of code on Python, which is not a joke. It's a very long algorithm, distributed in various parts. So all this is being tracked down and it's being improved by quantum computing. So if I run this on AI will take days to run all this data because it's not that advanced, especially on Python. But combining it with quantum computing can help increasing performance in a huge way. In fact, it can save me from weeks to days in getting results, right? So this is the power of implementing it on a daily basis. Now, let me just see what questions in the chat, which I can see there are many. All right, where was I last? All right, first of all, If we are talking about how AI works, applications, all that, I will discuss it later. In terms of operating system, I already told you I'm using Python right now. You can use Julia. You can use C++. Operating system, you can use it on, of course, on iOS. You can use it on Windows as well. Ideally, you should use it on Linux. Linux works pretty well for this, but if you use iOS, like I'm using right now a MacBook, so I'm using an iOS device, it's fine. And you can use a Windows device, it's also fine. Any operating system will do. It's not restricted to any operating system, so to say. But, well, a very powerful quantum computer won't be able to run on very accurate basis if you run it on a Windows device, as you can imagine. Now, what else is there? What are current research challenges in AI? How AI is ready for IoT? Well, research challenges in AI right now are basically ethics. That is one. Ethics in AI is very challenging because we are working from an ethical perspective of human beings. In fact, the algorithm I told you about, the HR algorithm, has some ethical issues, privacy issues, because my algorithm used to discriminate between women and men for some reason. And even when you go into recruiting, it used to discriminate on people who were maybe Chinese looking or Asian looking, dark skin color, white skin color. So the algorithm has this kind of parameters adhered to it. So removing that from the algorithm is pretty challenging. So that's a very hot area of research. Another hot area of research, as you can see right now, is healthcare and coronavirus and COVID-19. Because, well, as you can see now, in the last 2-3 months, something is very clear to me right now that in life we might have success, we might have money, and we might have anything we want. But if we don't have health and we are not healthy, we have nothing. So AI applied to healthcare is a very critical area and something which I believe is very important and needs to be widely explored, because unless it's explored in a very huge way, we won't be able to predict further pandemics in the future. In fact, in November 2019, the COVID-19 that we are all experiencing was actually predicted by an AI algorithm in China. But, well, Chinese authorities chose to ignore that and chose to go on their own. And then in January and February 2020, we all know what happened, how history took place. So AI can really help in this way, but it's a bit challenging. So my advice for those who want to research upon AI will be, first of all, focus on ethics, like as a topic, AI and ethics. Secondly, will be AI in healthcare. And lastly, will be AI, probably smart cities. So the future of the world is smart cities. And of course, I'm talking about research not only from an academic viewpoint, I'm talking about research from a job viewpoint. So if you want to get jobs into the field of AI, you have to go for where the world is demanding it. So right now the world is moving towards computer vision, means Tesla or any sort of autonomous vehicles. Healthcare, as you know, right now we need it more than ever. And ethics. These three areas are very hot. Any other area will be important, but won't be as relevant at the moment. So focus upon these areas if you want to research upon that. I see there's another question here.
Yeah, there were more questions, Dr. Raul, on a possible research area in a quantum AI. Also, there was one question: can we use a MATLAB for implementing AI?
Yes, you can use MATLAB for AI. In fact, I recently and last 2 weeks, I wrote a research paper on that. Yes.
There was one question: what are the specific use cases which we can expect in the financial industry, and how it can be integrated with the blockchain technology or with the AI?
Okay, so see, these questions come because people are confused. These questions come because people are listening AI, blockchain, quantum computing. They're coming all together. And okay, let's throw it.
Yes.
The problem is that, okay, we have to be very clear here. AI is one thing, quantum computing is another. They have been combined, that's fine. But blockchain is something different. Like we are talking about,
it's a different area. Yes.
Blockchain runs on Python as well, runs on C++, runs on various programming languages. That's fine. But you can run it on AI. That's also possible. In fact, I always teach my students how to create their own cryptocurrency, how to create their own blockchain on Python, which is fine. But blockchain is different. Blockchain does not only have to do with finance. Finance is cryptocurrency. Blockchain applies to supply chain, applies to healthcare, applies to data encryption, applies to many fields, education field as well. So it is possible to combine it. Everything is possible in life, but the problem is that we cannot try to do everything in computer science. Like we cannot take AI, quantum computer, blockchain, and think because they're all very famous terms and very famous words, put it together. Because
there is also one question which is combining two very different area. How cloud computing helps to overcome challenges of AI. So cloud and AI or quantum AI. Yeah.
Yes, so basically that's what I was showing. As you can see in the screen right now, that is a cloud algorithm. Like I'm using a quantum virtual machine. A virtual machine is basically cloud, like Google Colab. If you use Google Colab, you're using the cloud to run your codes, simply because your laptop might not sustain it. So if you have a laptop which is not that good, let's keep it simple, you use the same code in the cloud. So it runs with Microsoft Azure or with Amazon Web Services, with similar platforms on the cloud. So that is how the cloud enables us to run codes when we don't have the hardware to run it in our particular device. That's how it helps. And it helps us, of course, store the information up in the so-called cloud and keep it stored. And I can access it from different devices, my laptop, your laptop, my mobile phone, doesn't matter. I can access that particular code anytime. So that's how it helps in practical terms. It helps in many other ways, but this is the practical aspect of it.
Dr. Girish Tere, can you make Anand Upadhyay as a co-host? He is also having some research area. He can ask some question. Also, there was one question. Is there any special hardware which is used in a quantum AI?
Special hardware, yes, there's a special hardware. Well, if you run, normally when we talk about quantum AI, to run a powerful quantum computer, you need at least 2,000 qubits at the very least. So to run those qubits, you need to buy a quantum computer, which are being sold right now, but I hope your pocket is quite deep because they're quite expensive. They are not cheap at all. I will discuss later the prices and how it works and so on. But so far, only companies like Google, IBM, Mercedes-Benz, Apple are working around this area because it takes money and resources.
There is also one question. NLP codes can be used in a Python IDE, or we need some other tools to be used?
No, you can use NLP in Python. You can use it for speech to text, speech translation, text to speech, speech emotion recognition. You can use various tools on Python when it comes to natural language programming. That's not a problem.
Mr. Anand Upadhyay, you have any question?
Sir, how we can use this quantum AI for what facial recognition?
For facial recognition?
Yes. Because
well, so far, even, I mean, I'm right now in Hyderabad, and I can tell you that Telangana State Police is using it for predicting who is wearing a mask and who is not wearing a mask, just to predict, social distancing as well as who is compliant to the rules imposed by the government. If we look at other practical aspects when it comes to corporates, as I said, if you apply it to human resources, you can see what employees are entering the premises, what employees are leaving the premises without any sort of biometrics or signature. You can see what employees are feeling. Are they happy? Are they upset? Are they angry? What are the feelings? Exactly? Everything in detail. Well, of course, you can use it for security measures as well in terms of your mobile phone, unlocking your mobile phone. You can use it for photographs itself. You can use it for crime prediction. You can predict what crime rates might be available in terms of what actions people are conducting and who have been in the criminal database in the past and what sort of criminals who have been bailed out or have been discharged are walking around the streets. So all this is being used. If you look at the current world right now, it's being used for social distancing to keep the distance between two individuals. So that is also, a practical application at the moment. I don't know how it will evolve in the future. Facial recognition has n number of applications, n number. Even to, I don't know if any of you has been in Germany, but I've lived in Berlin for a couple of months. In Germany, particularly companies like BMW and Mercedes are implementing facial recognition in their vehicles in order for you to open your car. So the car will only open the moment you come in front of the door. There is a camera, it recognizes your face and it opens up. Other than that, the car will never open. So it's an application of it, hands-on application of it. Useful at some way or some, depends how you want to see it, but that is one of them.
Yes, sir. Sir, is any specific hardware requirement for quantum AI or quantum computing? Is there any specific requirement of hardware? Like what must be the configuration of your system so that you can implement the quantum AI? Because you know, a country like India, the people, they are facing lots of problems related with the hardware specifications. So can you recommend what should be the minimum configuration so that we can, as a student, if we recommend anyone to start the work, then how they can start? What should be the configuration?
Right now, as I'm doing this presentation, I'm showing you this code. This particular code runs on my MacBook, which is a regular iOS device. If you have a Windows computer as well, you can run it. I have run this on Dell computers, which are Windows 10 computers. You can run it on Linux as well. But the problem will be the number of qubits. The more number of qubits, the more computing power you will need. As an individual, unless you have nearly not less than $10 billion to buy a quantum computer, I'm sorry, you will have a tough time developing a quantum computer in a very powerful one, I'm saying. So unless you actually work for Google or IBM, because IBM has a very powerful quantum computer, it will be tough. On an individual basis, to try it and to learn how it works, you can do it on Python itself, like I'm doing here in front of you. That is not a problem. But it will be only with 26 to 35 qubits. Not something really advanced, but to start with will do. It's not a big challenge. So for students to learn, this is the way, using the regular open source programming languages that you can easily download.
Okay, sir. Thank you.
With this, we can, is there any other question? Now, with this, we end of the session. Over to you, Dr. Vinit Vaidya.
Thank you so much, Santosh. It was indeed a great pleasure and pride to witness this particular session where Dr. Raul has talked about all the fundamentals which are required consideration for the artificial intelligence. And I think the future is going to be ruled over by artificial intelligence because the human power needs some kind of a support IT sector. Again, thank you so much, Dr. Raul, for your contribution towards this conclave and such an informative lecture. And definitely our thanks are due to our principal as well as Dr. Santosh. But to propose the formal vote of thanks, may I kindly request Dr. S.D. Asgekar, the Vice Principal and Convener of this conclave, to please come up. Dr. S.D. Asgekar, over to you.
Yeah, thank you, Vinith. Well, thank you, Dr. Raul Rodriguez, for an enlightening and enriching presentation on the topic quantum artificial intelligence. We appreciate having the clear focus on the topic. In spite, the quantum artificial intelligence is yet in the conceptual research domain. Thank you very much, sir. As you all know, the organization of such events are generally the result of close cooperation among several institutions and individuals. It is my great pleasure to express on behalf of the organizers a deep appreciation for the support and encouragement provided by the management and the principal, Dr. Mrs. Chaitali Chakravarti of the Thakur College. I feel privileged to Dr. S.K. Singh, our IQC coordinator and also conclave convener, for acting as a catalyst and organizing such a productive international conclave. Our sincere thanks to all the participants who are the actually reasons for the successful conclave. Thank you everyone, especially Dr. Raul Rodriguez, Professor of Artificial Intelligence, Machine Learning and Robotics from Vaksin School of Business, for associating with Thakur College of Science and Commerce for this particular session. Thanks especially to Mr. Alad Kawadikar from Netherlands for joining the platform today morning. Thakur College of Science and Commerce feel proud for having own alumnus with us today. Thank you, Mr. Alad. Thank you very much, everyone, once again, and wishing fruitful outcome from remaining sessions scheduled on the third day of this international conclave. Thank you very much. Over to Dr. Vinit Vaidya.
Let me add one small point here. Yesterday night, just I pinged Dr. Alhad, like, are you available? And immediately he says at 11:30 p.m. And today morning he was available. So we are very proud of you. He is our prestigious alumni and he is always there. Thank you, Dr. Raul, for joining us. And the feedback link is available here in a chat box. All the participants, please fill up the feedback link and due to overload here, the certificate you'll be getting in next 4 working days. Essentially, you need to fill up the feedback link here, which is available in a chat box.
A very nice topic selected, Santosh sir. Excellent.
We'll just, the feedback link will be available here for next 2-3 minutes. In between, the guest can sign off. Thank you so much, sir. The participant, those who have filled the feedback form, they can sign off. The e